Hey there, this is OneUpIndie here, coming with one of those rare epic video tutorials on remaking or making such a map in GameMaker. And as you can see on the right side, this is what we're going to do. No real coding part, in quotations, no real coding, because what we're going to do is just going through what all the pieces mean in this video tutorial. And of course you can download the whole project for free if you like, because this is a little bit too long, a little bit too convoluted. I just want to give you a step by step, so each piece has a specific meaning, what it does, why it does it, and therefore you can just recreate it. So therefore hopefully this will be a lighter to digest video. Of course the content is quite heavy, I'm not gonna lie, so therefore I'm just trying to explain it step by step, what it does, what the process was of creating it, and then of course you can just apply it to your own game. So if you want to join me on this hopefully not too long journey, because last time it was like 25 minutes, try to compress it to a little bit less, then stick around. This is OneUpIndie. I am a developer, so if you like what you're seeing and hearing, then why not consider sharing, liking and subscribing to the channel, of course. So little word of warning here, I'm just gonna first of all describe all the stuff, what it does, what it means, but this is content for my seasoned or more advanced users, so you need to understand what all this stuff means. I'm just gonna explain what the content is, what it does for the whole process. But you need to understand, for example, what arrays and accessors are and all that stuff, or DS grids and maps. Alrighty, so a few things in advance. So this is the mental process, how this whole thing has been created. So first of all, we needed to define a DS grid, and the grid of course has position, so from 0 to 9, so 10, so 0, 1, so basically it has a length of 10, but of course it starts with 0, so here 10 by 10. Of course you can define it the way you like, doesn't really matter. Then we are drawing these kind of, in quotations, empty sprites. So these ones are just transparent, so you can see where the grid is. And then we are looping an alarm, and each alarm has is doing one cell from each arm. So basically 4 times we're having a user event which is getting passed in the values of the specific arm of its position, and then it's doing some checks, and then these checks lead to the creation of this thing which you're seeing. So basically the spawning happens, each alarm is like 5 steps, but of course you can define it the way you like, doesn't really matter. This is just so it's looking cool. And then you are defining how long, for example, each arm can be. So this is a random value, and of course how many of those cells you want to have randomly also. So this is one of the presets, therefore a kind of very flexible system in this kind of regard. So let's jump. Should we jump? So no, so this is how that thing works in practice and quickly. So this will be, you will see in the video description, but of course you can download the whole thing and just go step by step with me how the whole thing works. So let's go into our object where all the magic is happening. So first of all, the create event, this is where we set up a few things. So the first thing is kind of important because we are drawing it. Go away. We define how big our entire map is. So here, for example, map 10. This is then later on being used to define and fill out all the positions of the DS grid. I just call it map here. Hopefully this is not confusing with a double loop with the width of the of this value for a DS map. And then we're just saying like, sweet, let's fill them up with those half transparent sprites. So this is what we're doing. And then we are basically drawing those positions. So once again with a double loop also. But let's, for example, each sprite has, how big are you? So I guess 15, yeah, 15. So here they are 15 by 15, so we got those nice openings, and then it can be just top, left, right, up, and then of course some are closed on these sides or on these sides, so they are defined. So here once again a 15 by 15 pixel block, a sprite. Therefore, because I want to have a little bit of a visual distinction, so that we are kind of that they are separated, so therefore a little bit of not a buffering but a padding, and therefore we just go 18 by 18 and just loop through all the sprites which we saved. So we are just drawing the sprite and we're just drawing each value which we stored, and these are sprite values, and then we're just looping through all the positions. So this is how a regular for loop should look like. Nothing too specific, nothing too difficult to understand. Here, just for us, so the whole thing is being drawn in the center. We're just taking the position of the camera, and then the camera plus the camera width and the height divided by 2, and then storing them to our X and Y position of this thing where everything is being drawn, so on the map generate. This is then up to you how you want to define it, doesn't really matter. And then of course we have a little bit of an offset to the top left, so here plus offset. Why do I do this? Because if the map would be in the center and then being spawned like this, it would look kind of silly, so therefore I just pushed it a little bit to the top left. This is the explanation of this part. And of course, so we can actually see it better, I'm just drawing a black box, so this is just a black sprite, and then the background is a little bit less dominating and you can see the map better. That's just for explanation. So here we get the position, and then we're just drawing all the points on the map. So here this is how that works. So the first thing which we need to understand is we are looping the alarm quite a lot and very fast. So you can see the spawning, which is looking pretty sweet. So here once again, this is the alarm in action, and then it has a refresh time, and then we are just looping well, as long as we have total spawns. So this is our first thing, which is defining how many spawns we want to have. So total spawns for all cells. So let's say you just want to have a total of 40 or 50 or 30. This is then up to you how you want to define it. And then additionally, you can define each arm. So arm length 1, 2, and 3. And as you can see, each arm has an X and Y position, and of course we store that into an array, so arm 1, arm 2, arm 3, and arm 4. So this is the current position of the arm, which is getting updated. So once again, total amount of cells, here a random length of an arm. Of course you can define that further if you like, so this is just for randomization, so it looks cool. And then the actual current position of the arm. Then we got our index of which we're just putting in here. So let's go into the alarm event so you can actually see what it actually means. So let's say, for example, we are toggling our alarm from the start. So here, and then we are just saying like, hey, let's check the arm index of 1. So we're just going into the arm 1 and then going through the user event. So first of all, we're just saying like, hey, total spawns minus. So we at some point are not spawning any, and then this is then just saying like, hey, we spawned enough cells, game over, no looping of the alarm event. And then we're just using this index value in our user event. So let's go, you don't want, no, not like this. So we just go into our user event, and here first of all we're just checking like, hey, storing that into a variable which is then called of our cell X and cell Y with a specific index. So we're just grabbing the current position of our arm of index 1 and later of index 2, index 3 and index 4. So this is how it works. It's just basically just saying like, hey, check index 1 and then go into the user event. That's doing all the stuff in user event, then returning to the alarm, and then it's setting the index to 2. Then once again user event, but here now we're going to the second arm, and then 3 and 4. So this is how it works. Hopefully not too difficult to understand. So the next thing which we then say like, hey, the total arm length is also getting reduced. So at some point we just end. And then this is now where all the magic is happening. So first of all, we're just checking like, hey, is the neighbor cell free? So in practice, this is how it looks like. So let's say we have a cell here. Then we're just checking, is this one free, or this one, or this one, or this one? And how do we define it? Well, we just check if the sprite nothing, which we assigned at the very start, so the transparent one, is it this one? Sweet. Then we can, for example, go to the right or go to the left. So how do we do this? We just theoretically check in our grid or our map or whatever you want to call that, +1. Is this spot on the right side from us, from the current position, is it free? So it has this sprite assigned. Then, of course, we need to make a second check, like, hey, if we are going to the right, is this actually still in bounds? So is it still on our grid? So let's say here, we can say like, hey, on the right side, there's nothing. And technically you would say, but we don't have to do that because there is no sprite here. So there's not SPR, nothing for the map. Yes, but we have a little error here, which is, come on, doing this part, index out of bounds. Index out of bounds means that, for example, we are, for example, checking in our DS grid map position which doesn't exist. So let's say 10, 11, 12, whatever. But we have to check this, but it doesn't exist. So technically it's a bad thing because it would crash the game, but it's not here. So this is, thank you GameMaker, by the way. So this is good. So let's say, for example, we're just checking position 10, or for example, position -1, or here -1 on the y-axis. And these things don't exist, but still we can technically check them. So normally what you would be doing is putting the whole structure here in kind of a buffer and have a kind of a buffer range of 2 cells which are never being used. So this is one way how to do this, but of course it works here, so let that be it. So therefore we're just checking once again for our max value from the right side, and of course if we are going to the left side, so cell to the -1, let's say we are completely on the left side, so let's say we are here, then we're going to the left side, sweet, the SPR, and then this is still a valid point, but let's say we are here, we're going to the left, there's nothing here. Then we just have a little bit of a check, like say, hey, are we still bigger than 0? So this is 0 is the very, very last index position on the left side. Then okay, and then of course we do the same stuff for the Y positions. And then we define like, hey, is the neighbor just free? So this is our first check. Then we just go like, hey, our sprite, what kind of exits does it have? And then we're just having a switch and going through the sprite. So for example, let's say our first sprite, this is definitely the first one, is the map start. This one we assigned at the very beginning because this is our starting point. So here we define a starting point, so map arm 1, and all the other arms also at 5. And we just say like, hey, this is our green one, which is the start one with 4 openings. All right, so define our start position, and then it's visually already there. So here we stored it there. Then we just say like, hey, what kind of openings are we having? And of course it has openings in all the directions at the very first time. So for example, if for example we loop it through the event arm 2, 3, and 4, then of course, I don't know, left is gone or up is gone, whatever. And then this is how it reduces possible positions, because these ones are openings, but you cannot go there because there's no cell free. And then this is what we do. First of all, can we go there? Technically, without any restrictions, and then is there a possibility because we have an opening from the sprite? These are the 2 things which we're checking. And of course, let's say we have this sprite, so let's say SPR map left and right, it has an opening to the left and to the right. That's how well I wrote that. We just say like, hey, we just have an opening to the left and to the right, and for now we are doing nothing. But now we can actually do something with those kind of things. So first of all, we're just checking, hey, can we go to the right? And is there an opening to the right? So if those 2 apply, sweet. Then we, of course, need to have some randomization there. And then we just make a bogus choice. and just say like, hey, we can go to the right, we can open the right, and we have chosen to go to the right, then our result we store on this variable choice result, we can definitely go to the right. And this is the thing which we want to find. But sometimes, let's say, these things we don't want. So this is how it works. So basically, we're just having those 3 or 4 conditions met. But let's say those other conditions are always met too. So at the very beginning, it would always go down. This is not what we want. So therefore, what we do, we want to just randomize it a little bit more. We're just checking like, hey, are we having a match of all those 3 parameters? Then the result is this. And then we say break. Break just means, okay, break out of the loop, because we're doing this 20 times. So we're just checking, okay, do we have one of those 4 combinations? Is one valid? And if it's valid, we just break out of the loop, and then because we found out what we wanted, and this is then stored in choice result. And now we go to the well, a little bit convoluted part, because now we have to apply and check in advance a few more things. So first of all, we just defined we can go to the right. There's an opening to the right, let's say, for example, and then we have chosen to go to the right, and then we store that into the variable choice result. And then we say like, sweet, let's do something with those informations, because for now we're doing nothing with that. And then we have 3 choices for each ending, for each well, sprite. So let's say we are going to the right side. So here this sprite is valid, so to the left and down, so it has an opening to the left and down. This one is valid because it has an opening to the left, because you go to the right, and it goes to the right also. Or this one is valid, but of course here the other ones are not valid. So here 1, 2, 3. But let's say we want to go upwards, so this one is valid, 1, this one is valid, up, and this one is. So as you can see, there's always 3 choices, because this is how the system works for each well, direction which we want to go. So here we have to check for those 3 choices. And once again, we do kind of this bogus system, once again checking 20 times, and just, well, picking choice 1 or 2 or 3. So here, once again, this is the same stuff as we do here, just call it a little bit different. And then we're just checking like, hey, if, and this is the double check, hey, can we actually input, for example, this sprite which is going from the left to the right? Let's say we can go to the right, which we already decided. This is then let's go into the thing. Oh, this one's actually better. So let's say we can go upwards. This one cell is, as you can see, visually free. Imagine you would have an opening here, then, but we cannot go further. So here we're just checking, hey, what kind of sprite can we have? One of those 2, 3, but all those 3 have an additional opening going somewhere. But the point is, we cannot go any further. So if we cannot go any further, so we have 3 fail safes. So the first one, if none of those 3 options apply, we just say like, okay, our SPR nothing, which we set as default, hasn't changed. So we just say like, hey, this one is an ending. So those blue guys here. So blue guys, I mean endings, so one of those here. Or the arm length is over, so it's just smaller or equal to 1. Game over, your sprite is set to, well, an ending also. Or for example, this is the last cell which we want to spawn. Game over also. So here once again, these are just the fail-safes. But of course, let's go through these guys, because I guess this is the more interesting part. So let's say we want to check, hey, can we actually input this sprite? So we already decided on the right side, we have space. And this one means, hey, we can go to the right and even one more to the right also, so 2 times. So we're just checking 2 times in advance, hey, what would the cell plus 2 look like? Is it a nothing thing? Great. And is it not out of bounds? Great. And we have chosen, well, choice 1 here. Then we can actually apply, and then we're just breaking out of the loop because we are doing that 20. Or let's say this guy here. So it just says like, hey, there's an opening to the left and upwards. So what do? Well, we're just checking, hey, if we go to the right, +1, and if we go upwards, -1, because here this thing has an opening to the top, is this also free? If yes, because then we build a connection, we just say like sweet, we can put this sprite in there. And of course we're just checking like, hey, hopefully we are smaller or bigger than 0. So basically 0 just meaning like, hey, is there, well, are we not going out of bounds also? So this is just what it means. And of course, if we have chosen 3, so this is then the bogus part, and then once again break and set these sprites. And of course, if we repeat this 20 times and nothing comes out, so here our default sprite is still set, one of those 3 fail safes will grab anyway. So this is how it works. And then the last part is just to the specific cell, because let's say we go to the right, cell +1 of the current one is now set to the specific one. So one of those 3, which is then set, or one of those 3 failsafes. So this is, so basically we always end up with or an ending point or one of those kind of linking points of an arm. This is how it works. And then the last thing, we just update, let's say, the X position, because we went to the right, and then of this specific arm we just go to the right. This is how it works. And then basically we do the same stuff for the left part, the up part, and the down part. So once again, 3 choices, 3 different kind of sprites, here and here and here. For example, here for down, 3 failsafes, apply, update the position. But of course, if you go downwards, we update the Y position of this current arm. This is how it works. And then once again, we apply it for the first arm, the second arm, the third arm, and the fourth arm. This is how the magic works in this part. So here, once again, very, very quick repeating of what we're actually doing. Defining the grid, the size, saying like, hey, we want a start position and draw that. So we are just drawing the regular points, so the empty ones, then our start position, and for then our first arm is going somewhere, so randomly. And then in our alarm event, we're just going through the first arm, the second, the third, and the fourth. And then first check is one of our 4 neighbors free. Sweet. Is then an opening from our sprite there also. Sweet. And then make a little bit of a randomization, like, hey, are those 2 conditions met, plus did we choose, let's say, to go upwards. Sweet. Then we say like, hey, let's go upwards, and then we need to define, hey, what kind of sprite can we have? So we got 3 regular choices, but if none can be applied because everything around it is closed, then we have an endpoint. Or if this is the last spawn, so the last cell to be spawned, then this is definitely always an endpoint. Or if the arm is over, so let's say we just have 1 point, so 1 cell, then we do an endpoint also. So once again, these are our 3 fail safes also. And then we just update the current position on the x-axis, so x plus or minus, or y to this specific arm. So we can move it, and then later on we use the same value just to check again if we can go further. And well, if we are on an endpoint, then we are pretty much done, because we don't have any opening, and then we cannot go back because this system just goes one way. Alrighty, kind of a long video, 25 minutes again. Oh, well, this is the way it goes. Hopefully you now understand how that works. Kind of not the most difficult process, but if you see the code, it looks a lot. It's not that much, but of course you need to end up all the possibilities and modabilities and how to get there. And once again, not completely a fail-safe system, because this is a simplified version, but it does work in GameMaker, and as long as it works, even though you're breaking out of the bounds, so yeah, the index cannot be 10 or cannot be -1 or whatever. If it works, I don't really care. So this is pretty sweet for me. Alrighty, that was it from my side. Have a good one. One up indie.